For our experiment, we're going to use an SN2 reaction with reflux. First, we add H2SO4 and then NABR. This causes the R group, which is the rest of our alkane, and the OH to form the R group here and the Br, which is our 1-bromoalkane.
First, take a 50 milliliter round bottom flask and weigh your 1 alcohol into the round bottom flask using a scale that has already been taired with the flask. Make sure to add the alcohol to the round bottom flask when the flask is not on the scale. Next, add your required amounts of other chemicals. In this case, the chemicals will be water and sodium bromide. The amounts will vary depending on the alcohol you use.
Attempt to dissolve all the compounds by stirring the flask, but be aware that not all of it may dissolve. Cool your solution and some sulfuric acid in 2 separate ice baths. Once cooled, add the sulfuric acid to your solution slowly using a Pasteur pipette. Keep both your solution and the sulfuric acid cooled during this process to help prevent the formation of hydrogen bromide, which is toxic. Add 3 boiling chips to the round bottom flask. Now your round bottom flask is ready to be added to the reflux setup.
Reflux is when the lowest boiling reagent or solvent is brought to its boiling point, which turns it into upwards moving vapor. The vapor then condenses, then runs back down so it is retained. This is usually done by applying continuous heat.
To finish setting up, clamp the round bottom flask to the stand with a ceramic pad just below it to help prevent heat damage to the flask. Connect an appropriately lubricated condenser to the round bottom flask. Make sure that the condenser is clamped tightly enough not to wiggle, but not so tight that the seal between it is broken. Make sure that the round bottom flask is clamped tightly.
If the top clamp is too tight, it may lift the condenser, breaking the seal from the round bottom flask. This would cause HBr to escape, which is dangerous if not neutralized.
Connect the top of the condenser to an appropriately lubricated vacuum adapter with a secured stopper at the top. The vacuum adapter also needs to be connected to a piece of tubing. The tubing will be connected to a 60 degrees glass funnel submerged in a flask of sodium hydroxide.
In this experiment, although it is not a reagent, HBr is easily generated by using a salt of HBr. The use of NABR in a strong acid, it has the capability to generate HBr and C2. In other words, during the reaction mixture. So in this experiment, the addition of NABR and sulfuric acid to our round bottom flask, the solution results in the formation of HBr gas. This gas then rises up through the condenser and is prevented escaping by the secured stopper and therefore preventing inhalation. Instead, the HBr gas leaves through the vacuum adapter and into the HBr trap. The acidic gas then neutralizes with the trap by mixing with NaOH. Once the reaction of our 1-alkanol is complete, the adapter tube, and the HBr trap must be placed into the fume hood to prevent any extra trapped HBr into the room.
It is important to get the direction of water flow right. If the water were to go into the top portion of the condenser, it would almost immediately flow down and leave out the bottom. This would not cool the 1-bromoalkane enough, which would cause it to enter the HBr trap. Putting the water in the bottom allows it to fully fill the condenser, which allows for proper cooling, allowing reflux to happen.
Adios, chemistry gang.